2.2, circles. All right, so to start with, it says to find the center radius form equation of the circle described, and then it says to graph it, but we're not going to do the graph it part. So center radius form, just as a refresher from your notes, is x squared plus y squared equals r squared. At some point I'm going to figure out how to turn this crazy thing off that the iPad does now, but anyways. So number 12 says the center is at 0, 0, and has a radius of 9. So with this formula up here, this is if it's at the center 0, 0. If it has a center anywhere else, then it is of the form x minus h squared plus y minus k squared equals r squared. So that's at center, hk. So for this first problem, we'll need this one, but if there's centers anywhere else, we need that one. So center's at 0, 0, so I just have the x squared plus y squared part for the left equals, now r squared would mean that I'm taking that radius and I'm squaring it. Some people try to cut the radius, like take the square root of the radius and then plug it in, but it's like whatever radius they give us is what gets plugged in. So this is 9 squared like that. And you can either leave it there or you can rewrite it as x squared plus y squared equals 81. I would take it either way. But the technical form is to just leave it as r squared, so if you left it that way, that would be fine too. Let's see, let's do one that's not centered at 0, 0. 18, I have a center at 4, 3. And a radius of 5. So notice that in the formula for a circle, it's always the opposite sign is in here as to whatever the actual center is. So the center was at hk, so when I put it in, it was negative h and negative k, or you can just say minus. So when I plug this one in, what do we think this is going to be? And then we square both of those things, equals, and then it'll be the radius squared, so 5 squared. And so that's all you would have to do for a problem like that. They just want you to set it up. Now, if you were to graph these, essentially all you would do is, like, if I go back to this one, just so you can see it visually, I'm still not going to require you to do this, but in case it would ever come up on, like, your SAT or something like that. It's been a hot minute since I took the SAT, so I don't even know if this kind of stuff would be on here. But this one that was centered at 0, 0, so that would be my center. And then essentially with a radius of 9, I would just have to count out 9 spots. And then I would basically just go out to the same all around, and you would just be counting. The nice thing about a circle is that obviously they tell you in every direction, so you can just count that many spaces to the right, left, up, and down, and then you can make your circle. It's probably gonna close enough. But anyways, that would be essentially what you would have to do to graph it. If it was one like this, they've already given you the center, so you would just put the center there, and then you would just count 5 away in each direction for the radius to graph it. So, like I said, you don't need to actually do that when you're doing these problems, but I just want you to see it just to be familiar with how to do that. And disregard the fact that my points are not where they're supposed to be. Let's see, let's look at another one that is not at 0, 0. 22. The center is at negative square root of 3, negative square root of 3. So the x and the y is that. And it has a radius of the square root of 3. The other thing is, radius obviously can never be negative because it's like a distance away, so radius is going to have to be positive. So just also be aware of that. So, based on that, what would my formula for this circle be?
X plus the square root of 3
Yep.
squared plus y plus the square root of 3 squared.
Equals?
The square root of 3 squared.
Yep. And so that's all you'd have to do for those ones. And like I said before, like if you wanted to rewrite this and just write this as 3 over here because the square root of 3 squared would just be 3, you're welcome to do that, or you can just leave it. All right, the next stuff is going to use the general form equation of the circle. So that is the one that's x squared plus y squared plus dx plus ey plus f equals 0. And so what they do is they give us an equation, and it says to determine if the equation has a circle as its graph. So essentially they're going to give us an equation that's going to look something like this, but it may or may not actually be the equation of a circle. We have to determine if it is or not. And so to do that, we're going to be completing the square. So this is going to come full circle as to when we were completing the square, like what this is going to come back to help us solve some stuff out. But it actually involves us completing the square twice to be able to do this. So, 28, I've got x squared plus y squared plus 8x minus 6y plus 16 equals 0. So just because this looks like this doesn't always mean that it's going to be a circle. I'm not going to say that this one is or is not. Obviously, we're going to find out. But just because it looks like that doesn't necessarily mean it's going to produce a circle in the end. So what I'm going to do is I'm going to reorder my variables so the x's are together, y's are together, and anything that's just a number, I'm going to move over to the right-hand side. So initially, I'm going to have x squared plus 8x. Leave a little bit of space because we're going to work on completing this square, and that way we don't have to write the whole thing again. Plus y squared minus 6y. Leave a little bit of space equals negative 16. So all I've done at this point is I put the x's together, y's together, and I got anything that didn't have a variable, and I pushed it to the other side. So when we completed the square, what we did was we added a box right on that side, and we said we had to take half the middle term and we had to square it and we had to fill in the box. But now I'm completing the square 2 times. But I'm going to treat these like their own individual equations when I do that. So I add a box on this side. And what I do to one side, I have to do the other. So I'm adding a box for the x value, or for the number that's going in for x. So I'm going to put a box over there. I have to do it again, so I'm also going to add a box for the y, and whatever I do to one side, I have to do the other. So when it's all said and done, I'm actually adding 2 boxes to do this. But I'm going to be working independently on each thing, but it's going to produce one answer for me. Okay, so when I complete the square, I'm going to complete the square for x, then I'm going to complete the square for y, and put those numbers over here, and then I can solve the equation down. So when we complete the square, we take half of whatever the middle term is. So this is 8, so I take half of 8 and I square it. So what number would that be? Yes. I was thinking 8 squared for a second, and I was like, huh? No. Yes. So over here, I usually like to write it as whatever the number is being squared, but when I put it on the other side, I usually go ahead and square it. You can do it either way, but this makes it easier when I'm going to rewrite my perfect square trinomial. That's the reason I do it that way. Totally up to you. If you wanted to, you could write 4 squared over here instead of writing 16. It's just, I've done it for so long, this is just the way that I find it to be the easiest. So then I need to do the same thing here. So I need to half the middle term and square it. So what number would that give me for the y one?
9.
Yes. So 3 squared or 9. However you want to do it. Did you hand it at the office? Okay. All right, so now I can rewrite each of these things individually as their own perfect square trinomials. So, in keeping with the colors, I'll try to stick with that. So, when I have this piece right here is a perfect square trinomial. It holds the sign of whatever the middle is. So, this is going to be x plus 4 squared. And if I were to FOIL this back, I would get it back to x squared plus 8x plus 16. For that. Then for the y one, I'm making this a perfect square trinomial also. The middle sign here is negative, so that means the sign inside is negative. So plus y minus, as I write a plus sign, 3 squared. And if I FOILed this back, I would get y squared minus 6y plus 9, just like I had there. Equals, well, negative 16 and positive 16 go away, so it's equal to 9. So now, what does this look like? Like this whole equation, what does this look like? The equation of the circle that I started with. But what do you notice about this equation here compared to what I have down here? Okay, yep, this one's positive and that other one it was negative. What do you notice about my answer?
It's not squared.
It's not squared, but can I rewrite it as something squared?
Yes.
What would that be?
3 squared.
3 squared. So I'm going to have x plus 4 squared plus y minus 3 squared equals 3 squared. Now, the critical reason that I need to rewrite this as 3 squared is because when I go to say my radius, the radius is whatever number is being squared. So if you don't rewrite it, you're going to probably write that the radius is 9, but that's not the case. Okay? So, what would my center of my circle be based on this? When it was x minus h and y minus k, it was at hk. So what would that tell us our center would have to be for this one?
4, -3.
Flip the signs. Signs are opposite of whatever they are in here.
-4.
Yep. Because up here, these are both minus, and in here they're both positive. So make sure you flip the signs on that. And so then my radius is what? 3. And so that would be the answer that problem's looking for. So we had to complete the square 2 times and then get it into this like standard form, or what do they call it? Center radius form of the circle to be able to determine what our center and radius is. Let's see. Let's look at 2 more. 30. X squared plus y squared minus 12x plus 10y equals negative 25. So notice compared to the last one, the difference in this problem is that they already have the number on the other side by itself. But what I need to do is I need to basically rewrite the stuff on the left with the x's together and the y's together so that I can then complete the square. So I'm going to have x squared minus 12x, leave some space, plus y squared plus 10y, leave some space, equals negative 25. So then I'm going to add my boxes. So I'm adding a box here to complete the square for x. Whatever I do over there, I have to do over here also. Then I need to also add one for y. Now, a couple things as far as determining if this ends up being a circle or not. So the last one, we had the center, we had the radius of 3. If the radius comes out to be, like what would be the radius comes out to be a negative number or 0, it does not make a circle. Okay? So I need to complete the square over here. So what number is going in this box? Yep. So 6 squared or 36. And what number is going in this box over here for y? Yep. 5 squared or 25. So now, what would my perfect square trinomial be for x? Like if I wrote this in factored form, what would it be? Look back up there for reference.
X plus 6.
So whatever the middle term sign is the sign. So this will be minus 6 squared. And then what about the one for y?
Y plus.
Yep, y plus 5 squared. And that's equal to negative 25 plus 25. That goes away, so 36. So, can I rewrite this as something squared so that it can be in the radius, like in radius form? What would that be?
6 squared.
Yep. So I'll have x minus 6 squared plus y plus 5 squared equals 6 squared. Now, if it's ever a number that's not a perfect square, is that to say that it can't be something squared? You can always write it in a square root of the square root of whatever the number is squared, and that would also work, which I think they're going to pretty much be nice to you and give you ones that actually are perfect squares, but in case they don't, that's what it would be. So, where is my center of this? Yep, so opposite sign, so 6, negative 5, and my radius is? Yep. All right, so both of these so far have made a circle. Let's see if I can pick one that somehow is going to come out to not be. Wild guess, I don't know. Let's try this one. 36. X squared plus y squared plus 4x plus 4y, plus 8 equals 0. So let's see if y'all can tell me what to do with this one, start to finish. Yep. So I'm going to get the x's together. I like to go ahead and leave room. If you don't leave room, like, that's okay too. Plus y squared plus 4y. And what do I do with this 8 over here? Move it over. Yep. So by subtracting, so negative 8. Now what?
Add your boxes.
Add all my boxes. I'm not going to do them in different colors this time. I'm just going to. So I added 2 boxes on the left. That's a skinny box. So I need to add 2 on the right. So what's going in this box? 4. Yep. And what about this one? Yep. So same thing. Huh?
It doesn't come out to a circle.
So this would over here, what would the perfect square trinomial be for this? X plus 2. And then that whole thing squared. Y is going to be the same, just with a y instead. Equals -8 plus 4 is 0, but I can't have a radius of 0, right? So this is not a circle. So any questions about those? All right. Then as far as problems go, 13, 19, and then 27, 29, and 33. And I can't guarantee that out of those 3 that they are or not circles because my book doesn't have the answers. So I don't know. So they might all be circles. None of them might be circles. I don't know.